Jason Bloomberg. I am president of Intellix, an industry advisory firm focused on agile digital transformation, and I also write for Forbes, so you'll be seeing at least one article about this conference. And we have an esteemed panel here, so instead of introducing them myself, I will let each of the panelists in turn introduce yourselves. And the panel is on microservices and the Internet of Things, which don't necessarily go together. So let us know what your company does and just a bit about how your company is related to either microservices or the Internet of Things or how they're connected. So Lori, why don't we start with you?
Hey, I'm Lori McVitie. I'm with F5 Networks. I'm a principal technical evangelist. So I look at all these emerging technologies like microservices, IoT, SDN, DevOps, and figure out how they apply to the business. We deliver applications, right? We make them fast, we scale them, we secure them. So our interest is primarily around microservices. Obviously, it's a new application architecture. How can we make sure that we still are able to provide those same kind of functions for a microservices environment? Same thing with IoT. You've got a lot of data and a lot of applications that are going to be managing a lot of the functions those devices actually perform. Activation, registration, interaction with users. So, we need to figure out how to secure that, deal with access, and make sure that they're available and that they're fast and scalable.
Hi, I'm Troy Topnik. I'm the technical product manager for Staccato, a product by ActiveState that is platform as a service. And we've been getting very interested in microservices because it turns out platform as a service is a really great way to deliver that. So a lot of my opinions I'll be proxying for John Wetherell, who's our technology evangelist, and Bernard Golden, who's our VP of strategy, who have been looking at, respectively, microservices and the Internet of Things and seeing how we can start building a better platform to support both of these things. Because we've noticed that the Internet of Things is really taking off, and all those things are sending data somewhere, and they tend to be monolithic things. So we've also got this new design paradigm for microservices, and we think they might be a really good match. So we're trying to figure out the way to build the best platform for these emerging paradigms.
My name is Otis Gospodnetic. I'm the founder of a company called Sematex here in Brooklyn. We provide services and products, and the services are for technologies that are frequently used in the IoT world nowadays. Things like Elasticsearch, which a number of companies are now using to storage large amount of IoT data, other types of data, but a lot of data that kind of grows in volume over time a lot. We also provide monitoring service called SPM, which is important in a microservices context for monitoring the actual containers that run microservices or monitoring the applications that run inside the containers themselves.
I am Roberto Medrano, Executive Vice President of Acana. We are a product company. We sell products to companies that are doing web services, APIs, microservices. We start from the development side, how to develop the right services with all those three components, with a lifecycle management that has a registry, a repository, as well as has connectivity with DevOps. We also do the runtime. How do you run the right services the right way with an API gateway? And if you want to promote APIs at this point, you can use an API portal from us and do some analytics as well. So it's Acana. We've been in business for about 10 years, and we have about 300 of the large Fortune 1000 companies as our clients.
Very good. So a question for the audience. How many of you know what microservices are? Okay, we got about a third of the audience, so we should probably go ahead and define them. So somebody would please volunteer to do the duty. I will if nobody else will, and let us know what microservices are.
I do a first run, and the rest of the guys can help us. Microservices is a new way to develop applications, and some people call it services as well as the web services, but it's a combination with the principles of SOA, which is agility and reuse, as well as the new containerization like Docker and others, and also a new way to do DevOps. So the three components help you do a new scalable, flexible way to build new applications. Do you guys have any other stuff?
There's a bit of a cultural change that goes to building these things because, when building monolithic applications, you might have a very large team that has to take into account all sorts of moving parts. Whereas with microservices, you can split out and specialize to a certain degree. You develop, when you sort of break up a monolithic application, you can have small teams that update, that do one thing very well. And I can't remember who was using this analogy yesterday, but it's very familiar from the old Unix way of doing things. You make a small application that does one thing, does it well, and then you can chain these things together. The chaining that happens in microservices is generally done with APIs. The components talk to each other, these small components, and these components can be updated as you go. And they work really well when they're containerized, because then you can deploy them in the cloud. Does that make sense?
Yeah, it makes sense in terms of the skills that you want to use for microservices, because they're new skills in DevOps, new skills on breaking your applications and monolithic applications into other things.
So it's a design thing, but it's also a people thing in how you organize teams to build this.
I'd add one thing here, which I think, as somebody who was new to this as well at some point, I can be confusing, which is mention of a couple different, somewhat new things together. So at least this is my opinion. I don't know if that's an official definition somewhere, but we're mentioning services that talk to each other, take a big application, break it up, and launch individual small applications that talk to each other. And we've also mentioned containers. But those two things don't necessarily have to go together. You can have, you can develop a product, run a service that uses microservices concepts, but does not use containers, right? So that's, I think, something that people mention together like it's one thing. It's not. It's just that very often nowadays, now there is an option of containers. It does make sense to package things that way and deploy them that way and orchestrate them that way. But it's not necessarily one and the same.
So I would like to add that you can define a microservice as a parsimonious unit of execution. So a unit of execution, it actually has code in it. This is different from a web service. In the first generation of SOA, we talked about web services, and those were XML-based contracted software interfaces. So when we talked about a web service, we were talking about the interface, the idea being that if we have a software contract, we can abstract the underlying software, and that gave us a level of loose coupling. Well, microservices are actually code, but they're more than just code. They are the code plus the local execution environment necessary to run the code. So they can be the runtime environment as well as the caching underneath. So it's a whole unit of execution. It's like a little mini application in a way. But it's parsimonious, which is another way of saying miserly, right? As small as it can be, but no smaller. So instead of one of the problems we had with web services is they often tried to do too much. You had one web service with hundreds of operations. A microservice, that's what gives it the micro prefix, should do one thing and one thing well, and should be as small as you can make it, but no smaller. So it's part of the design decision when you design an application based on microservices. So as one of our panelists said, they lend themselves to containers, but you can do microservices without containers and containers without microservices. But part of the definition of having a unit of execution is it makes it highly compatible with containers. So to get back to our topic of the day, microservices and the Internet of Things, I Googled those two words because, like, what do these things have to do with each other? And one of Lori's articles came up first, and she's talking about this notion in that article about purpose-driven networking. So, Lori, would you let us know what you meant by that and how that ties together microservices and the IoT? Okay,
sure.
You wrote the article.
I wrote it. I had to reread it. There's, one of the things, so you're talking about microservices, you're breaking these things down, usually in functional blocks. Rather, SOA was really about objects, right, like customer, whereas when you look at microservices, typically people are doing more functional things. I want to do a catalog search. I want to do a login, a checkout, these kinds of things. Well, when you start looking at Internet of Things and you start looking at what do those devices do, any of them, some of them have to be registered, they have to activate, they have to be configured, they have to be controlled, right? There's very functional things that each of them do. So when you look at it, it's really kind of IoT is on this side, the things, and then you've got microservices kind of serving them in the middle. So the notion here is to really, kind of pair them up, that we see that's probably going to drive a lot of microservices because it makes sense. It's very functional, tight, very fast and agile, and everybody knows Internet of Things is moving very quickly. Every day there's a new thing you can get. So these things are pairing up very nicely. From my perspective, then I start looking at, okay, how does the network have to support that? Right? Because you're not just going to be connecting directly to this application. That doesn't happen no matter where you are. And some of the things you have to worry about are things like performance, scaling things, doing access. And then you start thinking about the difference between a person interacting with an application who demands it in now. It should have loaded when I thought of it, right? As opposed to a machine that maybe doesn't need to have that instantaneous access. And how, from a networking perspective, just an architecture perspective, do we start looking at, being able to identify not only what thing is connecting, is it a thing or a person, but why is it connecting? So what's its purpose in actually talking to this application? Because it may be a person one time or a thing the next time. Maybe we don't have to use network resources to improve performance for the thing, but we do for the person. So that's kind of the concept behind them and how I see them tying together and some of the things we're going to have to think about in the future in order to make all of this actually work.
Anybody want to add anything? Okay, well, on to the next question. You want to add something? Great.
Something occurred to me as I was thinking about what we were going to say here in terms of the things and people. It could be either of those. It could also be another microservice. And we're not only thinking about breaking up our own monolithic applications to make these things. We're talking about different companies, different providers, different people with interests. Some new disruptive technology can be implemented with one microservice that feeds into an analysis engine that does something new with the data. So it's not necessarily just your own company's collection of microservices. It's exposing APIs that allow microservices to tie into that and extract unforeseen metrics or unforeseen insights, as Cisco was bringing up this morning, to the long tail, everyone else, part of larger ecosystems that are building these things.
So one of the important benefits of microservices is they can be independently scaled, right? If you build an application by chaining together or collecting multiple microservices, as Lori was saying, you might have one that deals with login, another that deals with a dashboard or whatever it is. Well, the login may need to scale more than the dashboard, right? So you're breaking up an application and you can scale different things in different ways. So that now ties into the Internet of Things. So the question for the panel is, well, how can microservices help scale the Internet of Things? So focusing on scalability in particular.
Didn't you just answer the question? I think you answered your own question, right? Because you can.
Well, there should be more to it than that.
Well,
Go ahead.
Being from a scalability company, maybe I can answer this. So I think you hit the nail on the head. When you scale a monolithic application, right? Monday morning, everybody comes in, they're all logging in. The whole thing has to scale. Every instance of it. That takes a lot of resources because it's the entire application that you have to scale out. In a model where you might break that up into, well, here's a login service instead, you only have to scale the login service when you need it, while the rest of the application and services aren't actually consuming any more resources than they need. So it's more efficient in terms of how you can scale these out and when you can scale them out, because you can start scheduling it, you can do it dynamically, you can really manage to do a lot of different things that make things more efficient, and then of course faster, because one of the operational axioms that everyone should know is that as load increases, performance decreases. So microservices help spread that out further so that you can maintain the right amount of performance along with that scale. So microservices is really a good way to be able to kind of get the scale and performance you need without using too many resources, making it too costly, right? So you don't have to have the extra servers or all the extra instances.
There's one more thing that I could add to that, I think, which is that when you have an application, or when you take your big monolithic application and you break it down into smaller apps, let's call them, or microservices, some of them are very memory intensive, some of them are very CPU intensive, some of them need a lot of disk, or do lots of disk I/O. Nowadays, especially with the cloud computing, there are different types of instances that you have. Some have more memory, some are better at they have more computing power. So when you have your application broken into these smaller pieces, it's much easier to make better use of resources. You do not necessarily need all of the CPU on a machine, but you need more RAM. So you utilize things better by launching microservices on the instance types that have what the microservice needs. Right?
And that's where you come into it from a monitoring perspective.
Yeah, I guess.
Because you can find those
didn't
choke
think that
points.
way, but yes, yeah. I come to that from a perspective of a business that wants to have that situation in the sense that I want all of our instances to be utilized 100%, not 80,
Yep.
Unless we have to handle spikes. But microservices allow that utilization, the most optimal utilization of what's available, basically saving money.
Right, so one of the challenges with microservices is they externalize management, right? With a monolithic application, often management capabilities may be part of the application, but a microservice just is too small to deal with management. So you're externalizing management, and you end up with a lot of these things that need to be managed. And an aspect of management has to do with the APIs. Microservices are accessed typically via RESTful APIs, and that's part of the microservice pattern. So API management now becomes a central part of the microservices story, and by extension, the Internet of Things story. So the question for the audience, or for the audience, the panel, is, well, what is the API management story for microservices, and especially in the context of the IoT?
Well, Akana is an API management leader according to Forrester and so. So we've been specialized, starting with the web services to the API sides, in terms of managing, monitoring, securing those APIs and web services for now a long time. And we have a lot of customers using it. Now, with the principles of SOA, also you can do microservices as well. Now, the key is how are you going to secure microservices, and how are you going to monitor and manage those microservices as well. So we also providing those kind of services today for that, which is a new interesting way of monitor, management, and securing those things, because people used to do management of applications in the past. And the very few people that now start throwing APIs without looking at the security and the monitor of the APIs. And pretty soon people are going to start throwing microservices without looking at those components either. So as you're doing that, try to research what you have to do in terms of those three aspects. And API management, we call it API management now, but it really is service management as it relates to web service. For us, it's a service. A web service, an API, a microservice is a service. So we manage all those services. And there's no need to manage and monitor now the big applications, because everything is a mini application, a mini service now.
It's hard to decide where the authentication should happen. I mean, as people who are designing platforms, we have to think about whether we should offload this onto the customers who are building these web services, these little applications. Do they handle authentication themselves, or do they build another microservice? Or do you actually build that into the platform?
Well, there's a lot of design considerations as to when you're doing microservices.
Yeah.
Not only what you mentioned in terms of that, but also your data store. Are you going to break your data store into multiple data stores? Are you going to put agents on every device if you're using containers or not? Or you use a micro gateway like we do? It's just a lot of design considerations as well as management and architectural considerations of microservices. Yeah. We just published a white paper, by the way, that you can get on akana.com resources about microservices and why you should care, and what are the tenets of microservices. If you're interested, you can actually learn that. And then you can go to Martin Fowler, which is a microservices expert, on his website, and learn more about the design aspects of microservices.
Okay, so you did mention monitoring as part of that Akana story, but I'd like to drill down a bit more into monitoring, especially in the context of a broader application, which might consist of many different microservices. So how do you deal with the monitorability of microservices in the context of the broader enterprise context, and then tie that to the Internet of Things, where we have this distributed wealth of third-party things out there, and now we have to monitor those as well. So he wants to talk about monitoring.
Well, probably us too. So for us, monitoring really means looking at the health of your service. Again, microservice or APIs. What's the health of that service? Is it running, not running? What is the SLAs that are going? What are the policies that you're looking at to enforce for those particular services? And what are the security components that you want to control around those services? So we move that into a device of some kind of a UI. And if you want to do more analysis or analytical stuff for both. We have an analytic engine that you can look at and look at even more higher level business aspects of APIs if you want to do that. And if you have your own data analytics, big data analytics, we pump that into that data analytics, like a Splunk or anything like that, because a lot of the large corporations have their own big data things. So you got to bring all that data back into the component, the users that are using those kinds of analytics for you, and that's really how we do it. And we enforce policies as well through a micro gateway. Different policies that you may need for that, especially security and SLA policies.
From my perspective, or our perspective, we provide monitoring agents and reports and analytics for a bunch of different applications, big data applications, search applications, databases, and so on, which are basically things that you may run in containers. You don't necessarily have to run those things in containers, but if you do, we can monitor what's going on inside the container, inside the application that's running inside the container. We don't look at services, like Roberto was saying, from the outside, but we look at what's going on inside the application, as well as what's going on at the container level, as well as the host of the container. And yes, this is something that I guess one has to, especially with microservices, where you have a lot of these containers potentially, you have to keep even a closer eye on that, because things can be going up and down all the time. And actually, when picking a monitoring tool for such a service, I think one has to pay attention to kind of whether the tool is suitable for that, because the world of containers is very, very dynamic. Things go up and down, change name, and so on. And there are tools out there that don't handle that well. The node goes, or container goes down, you may get spammed with alerts, or the containers get launched and stopped, and all of a sudden you have all data in the UI or something like that. So you really have to pay attention to whether the tool that you are choosing for monitoring and management can handle such dynamic environments.
We talked about this a little bit earlier, how Staccato, our Cloud Foundry-based platform, has a scaling mechanism that comes in. It monitors at a simple level the CPU utilization within a particular container. So if one particular device is feeding in tremendous amounts of information, or suddenly a number of devices become active on the internet and they are feeding in a great deal, we can sort of detect that and scale. But we also allow for third-party monitoring libraries to collect that deeper information in maybe a more meaningful way. We talked about New Relic, we talked about your stuff, that you can analyze it and see in what way that scaling has to happen, and then trigger, again, on our platform with the API, the scaling of a particular component to respond to maybe latency that's occurring because of lots of thermostats turning on at the same time or something like that.
Yep.
I think we also have to look at it from the system level. When you start breaking down apps into microservices, you may have an app, at least from the viewpoint of the user, right, that might have been built by using 3 or 4 different services. And the user doesn't know that this is one service and this is a different service. So from a monitoring perspective, if one of the services that makes up this system that the user interacts with or a thing interacts with starts having performance problems or fails, there has to be some way for someone to know from a system level to be able to impart that to, perhaps the user. Parts of the system are slow. We've seen that, pop up in web browsers. Parts of the system are slow. We don't need to know which one, just that it is, and that, responses may be delayed. So I think monitoring also has to be from a more system level where you can start piecing things together. Because even with monolithic applications, it's not just one app. We call them monoliths, but they're not. They have data sources. They have authentication services. They rely on LDAP or AD. And when you want to monitor that, you actually want to look at that from the whole system to say, yes, the whole app is working, as opposed to individual components.
So we've been using the word container quite a bit, and we sort of have a bit of a buzzword soup going on here with the Internet of Things and microservices, now containers. And I just get a sense that not everybody knows what a container is. So I'd like somebody to define containers for us. And we've already talked about containers and microservices, but how do containers relate to the Internet of Things?
I'm really reluctant to actually try and define containers. It's so condensed.
Somebody here better know what they are, right?
I'll tell you what I think they are. So containers are a way to compartmentalize a host. And we're not talking about virtualization. This can something that can happen on bare metal or on a virtualized host. And it's a way of safely divvying up the resources of that host so that smaller things can use it without interfering with each other. Now, the base technology in the Linux world for this is implemented at the kernel and was originally driven by LXC, the LXC toolchain. There are other technologies. We heard about Open Virtuoso yesterday, or OpenVZ, but containers are implemented on different operating systems differently, but the popular ones we're hearing about now are Docker and Rocket and these container management tool chains. But the containers at their base level are just a way that a host has or an operating system has to isolate processes from one another and limit the amount of RAM they use, limit the amount of disk that an application can use. And so there's all sorts of different ways to do that now and to orchestrate it across it. I mean, our platform uses Docker containers behind the scenes to host the apps or the microservices. Is that a good start? Does anyone want to pick it up from there?
I would say one thing. I think what you described probably, I think even word for word you could say, oh, this is a virtual machine. But the big difference is that just implementation, technical implementation, in a sense that with a virtual machine you get a whole operating system and everything is kind of duplicated in the virtual machine as in another virtual machine that sits on the same host and in the host. So it's basically a heavier thing. It takes 10 seconds to launch or 20, however many things are getting started. With the containers, they're much more lightweight. So you could launch them, stop them, launch them, stop them like that. And that's kind of an implementation difference.
They share the same kernel with a whole bunch of other containers,
yes,
which can be started and stopped very quickly depending on what you're using.
Right, so you could when you create a container, you can configure it so that it only has what you need for that particular purpose.
Exactly, and this is why it's actually
faster.
Good for microservices is because you are not dedicating a host to a specific
the whole operating
tiny
system,
little
all the
thing.
other
Like
stuff,
we see a lot of people, especially for microservices, using Node.js because it's evented and it kind of tends to work for those very well. And it has a very small memory footprint, and so you can get, dozens of these microservices running on each host and then spread those microservices across a pool of hosts for failover. Whereas if you're starting a VM for each of these microservices, there's a lot of wasted overhead. This duplicating the operating system level over and over and over again. It's an inefficient way to do it, which is why people always bring up containers when they're talking about microservices. So.
Yeah.
So
I'm not conflating it. I just want to be clear as to why.
Well, it goes back to efficiency and agility and flexibility. All those three components are part of not only of microservices, but also the containers as well.
So what does all this have to do with the Internet of Things? Containers, Internet of Things, how are they related?
You keep on bringing that up, huh?
You want to...
We just tend to know more about microservices, so we can talk about that. No, the Internet of Things is creating a tremendous amount of data, and it creates it at unexpected times and comes from unexpected places. And the idea is that a microservices-based application architecture can respond to that better and more efficiently. So if we are expecting a new rollout of, a system update for a whole bunch of routers, then we want, the little microservice that just is pulled for the availability of a new version won't necessarily have to scale fantastically, but whatever service is providing the download for that software update is going to have to scale very quickly when it's just providing the downloads for the software update or something. I'm a little short on examples of this, but in theory, these two technologies were made for each other, and they should work very well together, but we're only just starting to see implementations of this yet. So
let me just add to that, as I said before, services for us is either microservices or APIs. You see right now examples of big IoT, like a tractor, for example, like a big thing collecting farm equipment out there from Caterpillar, John Deere, some of those guys. They're using today's services, an API or a microservice, to get farm data from all over the world to bring it into headquarters and analyze it. That's a service. It's call it microservice, call it API. is what you bring back and you analyze the data and do things with it. Other examples is a jet engine that is bringing fuel back to you in a different way. Either you use the connectivity with the API, but it's got some application on it. There's a microservice that is doing some collection of data for you. For us, we manage and secure those connectivities. You manage and help with DevOps for the microservices. So there's a lot of examples. It's not just your little device or your watch. It's all these big things that are happening in the world that is a thing that needs to be probed, collected, and then analyzed, whatever things come back from that for whatever purposes you want.
I think if we look at and we dig down into containers, just like virtualization, it's another thing that contains an application. It's a deployment model. It's not really part of the application. It's a way to package it up and deploy it. There's no requirement that a microservice be a web service. Nothing.
No.
Nobody said it had to be.
No.
It might be some functionality that's sitting on your watch, right? So if you can imagine the way the containers work at least with Docker and other systems that manage the updates is you actually can have almost like an image, right? So a package that can be in a repository. It's not impossible to imagine that a device that needs to be updated, whatever little code is running there, might actually reach out to an image repository or a container repository to pull down new containers containing new functionality in order to do its updates. So, and it's just a possibility, right? I haven't seen that done, but it's not impossible to imagine because it's the same principles that are used on the other side, which is to pull those images from a repository and then deploy them. So I think we could see that happen with Internet of Things and containers specifically. They're still microservices, just we tend to lean toward the web version of them because they're so natural, but they don't have to be. They could be any kind of functionality.
I think it's because there's so many web developers
I
that
think
these
so, yeah.
things tend to
Yeah.
be written using HTTP,
Yes.
and there's other protocols available that you can use, and you can hook those up to your microservices as well.
But as you continue developing this thing, now you see principles from the old SOA that come back. The registry repository is very important now for microservices because you're going to have hundreds of thousands of microservices. So where are you going to put them? You need a registry repository. Not like the old registry repository I used to have before, but a new way to register those services and be able to use them in a different way, in a new way.
That's a scary thought. Now we're going to have a whole bunch of registry repository vendors,
We already have one.
Okay. So, when I did my Google, Google Microservices and IoT to see what would come up, a great example came up with the notion of a connected car. Connected automobiles are Internet of Things endpoints these days, and all the auto manufacturers are, rapidly innovating in this space. And one of the ideas was the notion of a personal cloud associated with each individual automobile. So each individual automobile might have, essentially a cloud instance in a container associated just with that one automobile as a way of sort of maintaining this personal interaction between the automobile and the cloud. So the question is, well, where does microservices fit into this story, this connected cloud, or really any kind of connected device story where it's more than just a dumb sensor, but now we have this automobile, which is a sophisticated piece of equipment, but it's still an Internet of Things endpoint. If anybody wants to theorize here.
It's not far-fetched. I mean, today when I sit in my car, I got my buttons for my seat where it is. That's personalized to me. My wife has got the button. I got my buttons for my radio or my music. That's personalized at the car level. So now you can personalize it to a cloud level as well and put things up there, assuming the internet is always connected. And when you're in the mountains, you can still connect to it. But that's not a too far-fetched kind of example that you will be personalized in every single way, the way we personalize everything today. The personalized web is kind of here. The personalized, anything we do is kind of a personalized marketing that works for people. It's working now.
I thought about this example, and I immediately started thinking about how would you actually make this work, and I haven't got it figured out yet. But because when I think about Internet of Things, in relation to cars, I think of it in terms of auto manufacturers wanting to know how cars are performing over time and collecting data and then being able to upload that. And I would think that the sensors inside a car would be reporting to microservices that are configured for that sensor type across all of their cars. But when you brought up this example, I thought, well, no, wouldn't it also make sense to also send that information all to a place that is a collection container or a collection endpoint for my information that tells me how I've been driving over the past month and what days I've been using more fuel, or then not only does the auto manufacturer get metrics on how their fleet of a certain model of car is doing, but I can tell how my driving habits might be changing the way my car is operating. Or, it's a really neat example, but I can't think how you would do both or do.
Well, there's good things like anything. People that wear the Fitbits or the Apple Watch, they want to know how many steps they want to walk. They want to know what they're doing at all times. And sometimes they want the voice there, you better get up now and walk. I mean, we're going to have some positive things of that, but some negatives. Instead of the light of the oil change comes, some voice is going to tell you, better get it now down. Yeah. So it's all these things. Depends what you want to do with it.
Yeah.
So part of it goes back to the parsimonious nature of each microservice, that it just does a little bit and does it really well. And it has to do with how you're going to architect the cloud part of an Internet of Things application, like this connected car application. I mean, you could build some piece of software in the cloud that collects data from all the sensors across all the automobiles. And I'm sure they've been doing that. But now you have scalability challenges, right? Because you don't know how many cars are going to be uploading sensor data at any point in time. So if instead you have a separate piece of code, a separate individual microservice that interacts with potentially each sensor in each automobile, right? So if there's 100 sensors per automobile and 100,000 cars, then that's 10 million microservices. But because they're microservices, that's something that might be the best approach for dealing with it. Because now if you have more automobiles, you simply instantiate some additional services and some additional containers, and it's a way of scaling at that level. Whether that makes sense or not is still an open question, because now it becomes a management problem, right? Because if you have 10 million microservices, you have to put them in your registry repository, and you've got to spend all this money with Akana, but that's not such a bad thing, right?
So like this.
So anybody else have any additional comments, or should we move on to another question? Okay. Well, I tried to give a softball to each of our panelists. So Otis, I noticed that you're a search and indexing technology expert. So there's got to be some connection with our topic of the panel. So how are search and indexing relevant for the discussion of microservices and IoT?
A couple ways. So I mentioned earlier how we provide services, consulting services, expertise around certain technologies, search technologies like Solar, Apache Solar, and Elasticsearch. Lots of organizations, some of them whose devices you all have in your pockets, use some of these technologies to track various data that get collected from all of our devices, and they use this technology that was originally designed for search. Because of the use cases like that and some other ones like log collection, which is kind of similar, or metric collection, which is kind of similar, these tools are being kind of tweaked and redesigned to now no longer be good at only searching text, kind of Google-like query matching, but also handle analytical queries for various kinds of reporting and analytics. That's one reason why search technology is being used there. Second, some of it is built to be distributed in nature, which means that this, new version of some software is available. You need to handle more load. It's very easy, or more data volume. It's very easy to scale the application, to scale a cluster by adding more nodes with more space or more resources of some other kind. So it's a good fit. Third reason is that there are now nice tools that you can point to search software like Elasticsearch or Solar that allow you to both search data that's inside, but also draw pretty graphs and maps and charts and everything. Basically, BI tools that can work with not only traditional databases and warehouses, but now can extract data from these scalable distributed data stores. And I would say the fourth reason is that once you use the search technology, you can get this nice, pretty reports, but you still keep the search text search functionality in it. So if your data is not numerical in nature, if there's some text in it, you can still use the same technology to get insight from text. Let's say finding the most popular phrases that you have been collecting from devices, or something like that. So it gives you one tool that can get you kind of multiple pieces of functionality without you having to say, oh, I'm going to use this data store for search of this data, this other database for something else, and I'm going to store data twice and pay more money and use more resources.
Anybody want anything? Well, it does, it definitely brings up an important point of the Internet of Things, is where the real money is in the Internet of Things is in the data, right? It's in the information that these devices or the nodes, the sensors generate. And how we now squeeze that value out of the information is going to be the challenge that all of our organizations face, regardless of whether we're on the vendor side or the enterprise side. And so whether it's sophisticated search technology, better management capabilities, or just dealing with architectures that can provide the value from the data. That's really going to be the focus of the Internet of Things. So it's more less about the things, and it's more about the information that and the value we can get for that information. So we have about 3.5 minutes left. How about final words? So Lori, why don't we start with you, and just 30 seconds to wrap up.
To wrap up, well, my head's still exploding over this cloud inside a container concept. I'm kind of
Personal cloud.
Yes, my brain's fried. These are very early days. I mean, people are just starting to play with these concepts, but there are a lot of similar things going back to things like SOA, to virtualization. There's enough of the concepts that are similar that exploring it should be, a fairly, I guess, less painful experience than it was the first time these things were thrust on us. So at least we have some things that maybe we can learn from the past technologies that were kind of the forerunners and apply them as we go forward. So I think this is going to be an exciting time to see what comes out of it and what happens to it.
Troy, final words?
I certainly agree that it's early days. This is new stuff even for me, and the microservices I'm a little bit more familiar with, but we've come at it from the point of view of a Cloud Foundry platform provider, and discovering that this platform works really, really well for microservices. And then further discovering that microservices, in turn, are a really good match for the Internet of Things. So I'm just really interested to see where this goes from here.
My take would be that don't worry if this is all very fuzzy, because I think it's super fuzzy for everyone, not only in this room, but pretty much everywhere else. Lots of things are still moving and changing. I was at an event several months ago here in New York, very kind of grassroots, people who deal with kind of DevOps all the time, and there was a lot of talk about Docker. And then you ask this group of, 50 or 100 people, well, who actually uses Docker? Like 3 people in the room. So that's the level of use today from what I have seen. So don't worry if it's kind of all fuzzy and things, because things are changing. They will be different in 6 months.
Yeah, there's a couple of topics that we're talking about here. Microservices is one, IoT is another one. I see some of the large machines for IoT being already use things like APIs. Some of them are going to microservices, but they're using APIs today. Many of you that are using APIs or delivering APIs or doing SOA will go on to do microservices. So just start learning about the next things that you need to do. How do you do fast DevOps? How do you do containerization? You want to learn about Docker. Well, Docker World is coming up in 2 weeks. So we're a sponsor of that as well. And as you're learning, there's a lot of resources, not only on the web, not only on our website. You can learn about this microservice, you can learn about the APIs, what you need to learn, how to break out an application, a monolithic application, or even an API, and then move it into a microservice if that's what you want to do. So just keep on learning, keep on upgrading your skills if you want to go in that direction, but most of you will need to do something like that. The guys that says no APIs will be there. Now there's a lot of APIs. And microservices is here as well to stay. So just continue learning.
Well, that sounds like a good place to end it. So thank you very much, everybody.